Dive into the world of data center innovation with the iMasons podcast, discovering the people leading the industry revolution. My name is Roman Trenchon, and today I'm joined by Anke Beyer-Lout, wind engineer at CPP Wind Engineering Consultants. Together, we are exploring the impact of weather on data center designs and operations. So let's get right into it. Anke, thank you very much for joining us on the podcast and taking the time out of your busy schedule to actually come talk about wind engineering. It's a real pleasure to have you here.
Yeah, thank you for having me.
Why don't you start by introducing yourself to our audience and so we get to know you a bit better?
Absolutely. So my name is Anke Beyer-Lout. I'm an associate principal at CPP Wind Engineering Consultants. My background is meteorology. I studied weather at Penn State, and my focus was micrometeorology, turbulence, and dispersion. And I joined CPP Wind's engineering team right after and have been with CPP here at CPP's headquarters in Colorado for the last 16 years.
That's fantastic, and not something that we hear a lot about in the data center industry. Thank you very much for coming and sharing this. The first questions that really comes to mind for me is, what is wind engineering?
Yeah, that's the first question we get every single time. So wind engineering is a subset of mechanical engineering, structural engineering, atmospheric science, and applied physics. So all of the fun engineering topics are coming together. And a wind engineer analyzes the effects of wind, just like the name implies, both in nature and within the built environment. So we're looking at wind effects on terrain, wind effects on buildings and other structures. The roots of wind engineering really date back to the just about 1960s. And a good example of early really wind engineering and why wind engineering is really necessary is the Tacoma Narrows Bridge. Look it up on YouTube. There are a couple of videos out there that show that even during the construction of the bridge, that bridge started moving in the wind. So the construction workers named the bridge Gallop and Gertie, and that motion continued as they finished constructing this bridge, and it actually collapsed shortly after. So look that up. But this is one of the early examples of why wind engineering is important.
That would certainly make wind engineering actually a topic that matters a lot in general constructions. Can you just specify a bit more why it matters? Where is it coming from? Do you have any other examples of areas that wind engineering actually impacts?
Absolutely. So wind engineers have their fingers in all sorts of pies. They were starting with just structural wind loads and cladding pressures on tall building. Every single time you're trying to build a tall building, wind needs to be considered because we want to make sure buildings stand up to the wind. Wind comfort is another thing that wind engineers deal with. So comfort at street cafes, nobody likes their napkins blowing away. Comfort on pool decks, nobody likes white caps on their pool. Then we're looking at wind effects on solar panels, both the loads on the solar panels, as well as the potential for the panels to start moving and flapping around. Wind engineers also help with snow loading, snow drifting, snow infiltration, as well as air quality. So how do we protect our environment, indoor and outdoor, from building exhaust, that's industrial facilities or laboratories, dust, any type of harmful chemicals or odors? And this is really where data centers come in as well, on the dispersion side on the wind engineering dispersion side, really.
That's an amazing palette and array of areas where wind engineering is coming through. So now that we better understand the topic, let's talk about the people that actually are doing it. What are wind engineers doing today? What's the What was the new things coming to the market and innovation at the moment?
Yeah, so we're diving into data centers here. The main new thing is cooling. Data center, the density of the cooling equipment is increasing because rack densities are increasing. Cooling wasn't really a main topic until fairly recently, because no matter what type of cooling strategy is used inside the data halls, be it air cooling or liquid to chip or immersion, heat ultimately needs to be rejected to the outside. Assuming we don't have access to district heating where we can just ship our heat off, most of the time that heat is rejected to the atmosphere. And the cooling systems for data centers are at the mercy of weather conditions. And they're at the mercy of local turbulence. And that generally leads to recirculation and re-entrainment. And that's where wind engineers come in and can help. Because the accurate modeling of the interplay of all of the hot exhaust sources, that be generators, that be your dry coolers, that be your chiller packages, are absolutely important. And it is important to just reduce the risk of overheating. And risk is really the main focus here. There are a couple of things we can do on the wind engineering side is to really analyze that risk. How is that interconnected system of all of these exhaust sources on your data center? How are they interconnected, and what is the risk of overheating?
That's fantastic. Can you take me through the tools, methods, techniques that are currently being employed and deployed within data centers, and the sort of results that you're starting to see by applying all of those? It'd be fascinating to actually go through this, if you don't mind.
Absolutely. Yeah. So tools of the trade for wind engineers, starting with atmospheric models. So these are mathematical models that describe atmospheric motion. That's where sort of your weather forecasting models fall into that category. There's statistical models of extremes, that extreme climate, extreme winds. There are atmospheric boundary layer wind tunnels that we have here on site, both in our Colorado office, in our Sydney office, and in our Kuala Lumpur office. Atmospheric boundary layer wind tunnels where scale models are constructed and then put in the wind tunnel, wind blown at it, and then the quantity of whatever we're after, be it pressure, be it dispersion, is measured. And lastly, computational fluid dynamics models are also part of the toolbox that we use. And the focus for the tools, especially for data centers, comes into to understand risk, boils down to simulating or modeling all potential wind conditions, because we can't get an accurate idea of risk if we don't understand the interplay of all of these hot exhaust sources impacting each other for all wind conditions. And that is where the atmospheric boundary layer wind tunnels really shine. Because like I said, we can model all different wind conditions in the wind tunnel by just placing the model on a turntable and rotating it.
So interesting that things that have been done in other industries are now coming to the forefront of the data center industry. What sort of results are we seeing? Is it just starting? Are we already getting probing results from those existing techniques? Can you take me through this?
Yeah. So as far as results goes, like I said, for data centers, it's important to understand risk. And that interplay can get fairly complicated. So what we've done fairly recently is to come up with a dynamic system to simulate the cooling sources, really the cooling equipment, because it's not just as we would do for a laboratory exhaust, where you're modeling the exhaust and measuring how much of that exhaust comes back into an intake and make recommendations based on that. Cooling systems for data centers on the outside are much more complicated than that, because it's a dynamic system. If you have one dry cooler exhausting your heat from your building, that has the potential to come back into the neighboring dry cooler. Now all of a sudden your intake is hotter. That means your exhaust is hotter. So that dynamic cascading effect can get very complicated very quickly. So we had to adapt our modeling approach to include this type of feedback and to include this type of cascading effect. And the next step then is to include the chiller, for example, performance as well, because at some point the performance drops off if your intake temperature increases. And that drop in performance then leads to less heat getting exhausted, impacting the neighboring unit. And at some point, if the intake temperatures go up too high, the unit shuts off. And that is, again, part of that dynamic model that needs to be included to get a comprehensive idea of risk. What is the risk of overheating? What is my cooling capacity that I have for my data center?
So when we were discussing wind engineering in general before, one of the things that I asked here that was quite interesting is, at what point do you know that you need a team of wind engineers to actually come and access your data centers and start making recommendations? Can you tell our listeners what you told me before, and more specifically, at what point do we need to contact you, your team, or for all matters, actually any teams of wind engineers to come and access the sites?
Yes, so early engagement is what leads to most successful projects. That means even an early phone call during the site selection we can make sure that buildings and equipment yards are laid out in a way that minimize reentrainment. So that doesn't even involve a large modeling effort. That is just a quick phone call. And having that partnership through the life cycle of the project then leads to better outcomes, so that there are no bad surprises once the design moves to the stage where we want to look at accurate modeling and detailed modeling, so that sort of the glaring obvious things are already taken care of at that point, and we're just refining results and coming up with, for example, site-specific design temperature, making sure that the equipment is correctly sized, and that way we can increase resiliency and also prevent overheating. But yeah, overall, we are aiming for a partnership coming up, starting the project, so that we have somebody on call for wind or weather-related questions right away.
It's something I didn't realize before, but what if just reading through what you've explained, wind engineering is actually practically needed at every phase of the data center's life, from early designs, making sure the designs are correct, all the way through to operations. Is that correct?
Yeah. Obviously, we like to get involved early. Like I said, it's easy to fix things in the design, whereas it's harder to fix things while things are operating. But yes, every aspect of the data center design is really covered here.
That's great. I'm pretty sure there will be people that want to know more. Right? We're only skimming through the high level bits of what wind engineering is. What can they do to go find out more, figure out what this is, if they need it, who does it, the different techniques? Where can they find more information?
Yeah, the first step would be to check out our website, cppwind.com. Shows a lot of different examples of what wind engineers do and how to get involved. And the other part would be reach out to me. My email is shown here in the banner. And lastly, if you're anywhere in the area, either near Denver, Colorado, Sydney, Australia, or Kuala Lumpur, Malaysia, come to one of our facilities and check out our wind tunnels for a free tour.
That's great. One of the reasons we're having that podcast with you today is the fact that you've actually been part and been introduced into the iMasons Innovation Incubator, which helps at raising awareness and also supporting the different companies that are coming to market and are doing things differently. Is there anything that you're looking for in particular within the iMasons community, or things that you would like to be able to accomplish?
Yes, so our first main goal is education, because wind engineering, while it's widely known for the structural design process, any type of tall buildings, it's also well known in the laboratory design environment. Wind engineering has not been a large part in the data center design. So education is the first thing that we're trying to do, just outreach. Let people know that there are other tools available. The next thing that is really high on my list would be a best practice guideline for sustainable data center design. We would love to partner with other players in the area to come up with, here's what you can do to make sure that the design is sustainable. The data center industry is not well known for sharing what worked and what doesn't work. So coming up with best practice guidelines would be fantastic. And lastly, I would love to partner with owners or operators who are willing to share historical data on equipment loads and temperatures for their data center, to develop a test bed and validation procedure for dispersion modeling technique. Because we've seen a lot of different approaches in the industry, and it would be great to come up with both guidelines and a test bed for people to really test their dispersion models and verify accuracy.
That's a complete program here of things that you want to do. I will put back actually the your email address on screen if anybody want to reach out. Anke, I've got one last question for you today. Everything we've been talking about are things that are currently being done within wind engineering. Some of the things extremely fascinating around technologies and methods and tools that have been used for decades that are now coming into the site of data centers. But what's the future? What's coming?
Yeah, the future is exciting, and the future is getting smarter. So I'd love to see if we can work with the weather. Whenever we're looking at data centers, we're cooling, we're working against nature, we're just forcing things in a way and try to overpower what that local climate does. And so if we would have a pinpoint local weather forecast, on-site meteorological station that provides us with real-time data of what the weather is like, and an accurate understanding of that reentrainment that is happening, for example, on the roof around the cooling equipment, can that help us optimize which cooling units to run? How can we increase our free cooling hours so that the goal is to maximize free cooling and optimize that with on-site weather observations? Would be great to look in the future. If we knew 3 days ahead what weather conditions there are, can we optimize and plan for potential heat waves or better cooling because it's going to get colder? So having that be a comprehensive system where we're not constantly working against the weather, but actually working with the local weather, that would be fantastic.
So beyond partnership with companies, partnership with the weather would be one of your dream accomplishments, if I hear you correctly.
That is right.
That's fantastic. Well, thank you very much for coming on the podcast today, taking us through what wind engineering is, and views of the future of the of wind engineering. If anybody want to reach out, I've left the contact details on the bottom of the screen. What I wanted to do to finish the podcast is welcome any of our listeners. If you are in the similar positions and driving innovation within the industry, we actually want to put out there actually the Incubator platform, which is actually being run as part of iMasons. The link is actually at the bottom of the screen. And you can actually reach out in case you want to have supports and connections being made within the iMasons general group. So on that note, Anke, once again, thank you very much for taking the time today. And for all the listeners, we'll see you once more very soon. All right. Thanks very much.
Thank you.